Password cracking as a service. My name is Siddharth. Me and my teammate Shreyash are going to walk you through our data center project, password cracking as a service. Our main goal is to provide a cloud-based scalable solution which provides password cracking for several users at scale. Our main objective is to provide a simple, clean, and user-friendly interface through the means of a graphical user interface, which we provide. We also provide a set of RESTful APIs that can be leveraged from a developer standpoint. We offer a select set of cracking modes. The first one being a single crack, which is the most basic one of all. You use the full names or logins as candidate passwords. The next one you have is incremental, which is basically a brute force of all combinations of sequences that you can generate. The password cracking utility generates based on the character sets or the digits or the punctuation that you provide. And lastly, we have the dictionary attack, rather called as the word list, where you provide a sequence of frequently used passwords as an input, and the password cracking utility attempts to compare your hash inputs against the sequence of passwords and attempts to figure out what the password actually is. To give a bit of background, companies in general do not store passwords as raw plain text in their database. They instead store their passwords in the form of hashes. And hashing is basically a function that takes in a given string, such as your password in this case, and attempts to shorten it always. And this shortened string is always maintained in the database. And now, for the context of password cracking, an adversary attempts to retrieve these passwords that are maintained in the database, which is nothing but the password hashes. And his goal is to actually come up with a reasonable password that represents this given hash so that he can make use, he has actually recovered the password. We have a select set of RESTful APIs that we can use. The main API is this /crack, which is a post method and initiates the cracking task in the worker side. We also have a word list API, which you can use to retrieve, an already existing word list that you might wish to use. You can get the details of a given task, such as a pending or running or completed state using task details. You can also decide to terminate a task if it is taking a huge amount of time using the terminate task API. And lastly, you can also get the list of all tasks which are in the queue using the pending tasks API. So this is the representation of a user interface we have, and we relate it with the corresponding schema that you see on the right. For a given user ID, you can provide a hash file to compare against, and then it contains the sequence of password hashes I just talked about. You can also decide the type of hashes that you're putting in. If you don't know the type of hash you have, you can set it to crypt. The common types you have are like the SHA series of hashes, like SHA1, SHA256, SHA2512. You also have like an MD5 or the elliptic curve set of types that you can input. You can also provide the cracking method, which is single crack, incremental, or word list that I described before. You can also decide which word list you can select as well. And lastly, you can click a submit task button, which actually changes the status from a pending state to in progress. Once the user gets an output, he actually gets a visual representation in this format. For the given hash in the left side, you get a password on the right side, and you also have the hash type as well. A user can also decide to click the terminate button to schedule a termination. So now we have a select set of components that we use. Since this is a data center project, we have several components that are in play. And for orchestration of such components, we use Kubernetes. The underlying password cracking utility is John the Ripper in our case, which is more of a CPU intensive password cracking utility. The third thing is to provide our user experience and user interface. We have made use of React heavily. And to actually store the inputs from the user and the password outputs that we have got from the workers, we make use of a relational database, which is MySQL. And for storing the word list and the user hash inputs as a file, we maintain the same using object storage buckets in Minayo. We make use of a RESTful Flask API for exposing our API interfaces, and we lastly use Redis for user sessions and message queues. Coming to the architecture, you can assume client sends a bunch of requests to the ingress, which in turn forwards those requests from several users to the web app servers, nothing but our REST servers. So the tasks are then forwarded to our queues all the way to the different workers we have. We have two types of tasks, so two different queues: the worker queue for handling a new task, and we have a terminate queue to handle the task which wish to be terminated. And we also have two buckets that you see over here. We maintain the word list and the hash inputs as well in these buckets. And worker listens on the Redis queues and performs the requested task. So that is how it has been programmed. We maintain our user inputs and password outputs in our relational database. And lastly, we have a log service that accrues all possible logs from all deployments and components that you have and consolidates all our log messages that you get. And this is mainly used for our debugging and troubleshooting initiatives, as you see over here. And for cluster communication, we make use of predominantly the pending task API to see if the tasks have been scheduled and what tasks are already present at a given point in time. We go through the log service messages that describe the relevant info, debug, and error logs during communication. To handle abnormalities, what we do is we try to isolate a given component and try to test connectivity manually. If things seem to be in order, we test its functionality as a black box. We then proceed to integrate that component to our system and see if it's functioning correctly. If not, our log service would actually report the corresponding error messages that we would desire. And even if that doesn't work, we proceed to remote login to the given component and validate it's working. So we do have a bunch of learnings from this activity. The main thing is separation of concerns. This is very important because we decided to decouple our front end or RESTful services away from the workers. This provides the ability to scale, the individual components in a decoupled and independent fashion. And what this means for us is, if we are bombarded with a set of user requests, we decide to scale up the number of front end REST services. And if we are also have a potential overhead of several worker jobs that are scheduled, we also can decide to scale the workers independently. And the other learning we have is accruing several database writes as part of database transactions, which follow the rules of ACID, atomicity, consistency, isolation, and durability. The advantages that we have taken out from this is only successful commits made data visible to other users, and concurrent transactions don't interfere with one another. We do have a couple of bottlenecks. The main thing being that our utility is CPU intensive. We would wish to have a GPU intensive utility instead, but it is complex to integrate GPU based alternatives with containers. And not all possible cracking modes have been covered at this moment. For example, we haven't covered the hybrid case where you can club two or more cracking modes like incremental or word list that I described before. Rainbow tables is also another important cracking mode, since you can decide to pre-compute your hashes and their corresponding passwords and check against new user inputs. The only trade-off is you need a lot of storage, which you don't seem to have at the moment. Lastly, we don't have a provision for accommodating mangling rules, which is a set of specifications the user could provide to dictate how passwords are derived and how they're validated upon. So now we do proceed to actually demo our system, and this will be taken over by Shreyash. As you can see, this is our front end. One input that we have is to provide a hash file as input. So we proceeded to provide our password hash file. The hash file, as I spoken, is a set of hashes that you see over here. You can have like a user ID colon password hash. That's kind of the format that John the Ripper accepts. After that, you can decide the hash type, from a selected set of hashes that you can decide. For now, we just choose script for defaults. And lastly, we would do a word list based cracking method, in which case we actually require a dictionary such as a word list. At this point, we already have a word list present in our Minayo bucket, which is called the RockQ word list. It's a popular word list. And yeah, so we have currently set everything as per expectation. And once we proceed to actually submit a task, we would get this dashboard. What has happened in the backend is we have already hit crack endpoint that you see over here. So in the crack endpoint, we generate a UID and start a task. So we also do some checks on the input, whether it's a valid input or such. And once it's valid and everything, we send the task to the worker using a message queue. So you can see we have other APIs also. The word is to get all the word lists, the task detail, to get the task details, like pending or completed or not. And some other like terminate APIs to like once you click the terminate button. Here. Yeah, so these are the set of functionalities we have. So at this point, we can expect the task to be running in our worker. And what we would do is, this is actually our worker code that you see. We go through an infinite loop where we check if a termination or a completion happens. And we get that from the information we get from the terminated complete queues. And if a given job is checked as terminated or completed, we proceed to publish the password outputs depending on the user ID that we provide. This publish actually attempts to send the information to the MySQL relational database that we have as another component over here. As you can see, we are still in the waiting stage. We are waiting for the process to complete. We can also decide to terminate if we wish and get all the passwords that have currently been cracked at this given session. So this is the output that we have got. We actually terminated the task because it was kind of taking time for retrieving the third password. So because of that, we decided to stick to a retrieval of two passwords at this point in time. Thank you.